Good morning, friends. In the last lecture, we have described the RO, that is the reverse osmosis, and its application. It is again the we can say that some sort of this the important part of this unit. Sometime the question will be there on based on this particular RO system. Generally, we are using that in our houses to purify the water. Okay, the principle and the mechanism of this particular thing we have seen in the last lecture. Today we have to see the numerical based on this particular topic. Calculate the molecular weight of urea if the solution containing the 2 gram of urea in the 81.3 gram of water boils at 373.21 Kelvin. Kb for the water is given 0.512 Kelvin kilogram per mole, and the boiling point of the water is the 373 Kelvin. 100 degree centigrade is there, that is expressed Kelvin. First of all, you have to read given numerical carefully. Then after reading the numerical, we have to identify the given things. What are the given things? Then, as we have seen already, delta TB is equal to Kb into m. Okay, m is nothing but a molality. You have to substitute for the molality. Molality is nothing but the Wt by W1 m2 into 1000. That we have already derived that equation for the molar elevation constant, molar diffraction constant, or some that particular you can see the freezing point and the boiling point. Then same delta Tf is equal to Kf into m, that we have seen. For the both the things, same things are there. Then what they ask to calculate a molecular weight, means M2 they have asked to calculate. What is given? The weight of the solid is given, that is the W2. Weight of the solvent is given, W1. Then the temperature is given for the pure solvent is given, and this solution is also given. 373.21 and 373. Then Kb is also given. First of all, you have to calculate the delta TB. Delta TB is nothing but a T minus T0, which is, and delta TF is equal to T0 minus T. That you have to remember. This is a basic difference in between these two particular parameters. Delta TB is equal to T minus T0. Substitute the values for the T and the T0. You will get the delta TB is equal to 0.21 Kelvin. Then we know the delta TB is equal to Kb into m, and m is nothing but W2 by W1 divided W2 by divided by W1 into m2 into 1000. Then rearrange the equation for calculation of the m2. M2 is nothing but the Kb into W2 divided by delta TB into W1 into 1000. Then substitute all the values. Kb is equal to 0.512 into W2 is equal to 2 gram, and W1 is equal to 81.3, and delta TB is 0.21. After simplifying, after multiplying this parameter, you will get that the M2 is equal to 59.9, that is approximately equal to 60 gram. You got this point? It is very simple one. Such a likewise means similar ground of means we can see you can say similar type of the that particular numericals will be there just by changing the values. Here the urea is given, there will be the another particular solute will be there. You have to first of all identify the given things, then you have to write the formulas, then you have to go the step by step, because each and every step is having the marks. Remember this thing, while solving any numerical, you have to first of all write the given things. What are the given things? After that you will get idea what we have to calculate. Then note the formula, then go step by step. Don't make the hurry up. Once you go the step by step, then your answer will be the perfect. Otherwise you are making the hurry up, then there will be the mistakes in the answer, because each and every step has the marks. Means correct answer is having the full marks. If you are missing that correct answer, then you will lose the full marks. If you want to the full marks, then put the values in the that particular your calculator properly. Then the another example is given. A 4% solution of 4 is given. Okay. 4.5% solution of a solid X in the water has the same boiling point as to 4 gram of the glucose in the water. If the molecular weight of the glucose is 180, calculate molecular weight of the X. Kb is 0.512 Kelvin kilogram per mole. See here. That is a particularly 4.5% solution is nothing but the what you can take 4.5 gram of this solid is present in the 100 gram of the water. Okay. Then see here. First of all, what we have to identify? First of all, we have to identify the delta TB. Once you know the delta TB, you can calculate the molecular weight for the another component easily because CX2 that solid X and the glucose is different one, but their boiling point is same. That's why we have taken this particular thing. What given we have to calculate the m2 for the x, but for given thing is w2 is like 4.5 gram, w1 is 100 gram, m2 is 180 gram, kb is 0.512 gram. Delta tb we can calculate. First of all, you have to calculate delta tb is equal to kb into m. Delta tb is equal to kb, you have to substitute for the m, then substitute all these values in this equation. After substituting these values, you will get a delta tb. Then calculation of the m2 for the x. What given? W2 is given. Okay, W1 is given and you have to calculate the M2. Okay, just remember this thing. Delta TB is equal to KB into M. Then here M2 will be the 160 gram. After substituting all these values, you will get the answer 160 gram. I have given the number of numericals to solve this particular thing. Define molar elevation constant, a solution containing the 2 gram of non-volatile solid in the 100 gram of the water boils at this particular temperature. Calculate the molecular weight of the solid. Given things are there, then the calculate a boiling point of the solution containing 1.02 gram of this anthracene. Molecular weight is given in 70 gram of the chloroform. The boiling point of the pure chloroform is that, and its ebullioscopic constant is given. Okay, an aqueous solution of the compound A. Number of numericals, similar type of the numericals I have given there. You have to solve it. See in the third, I am not taking this. We will take the fourth one. What is there? Fourth one, calculate a boiling point of the solution containing 1.02 gram of anthracene. Means you have to identify the given things. You have to calculate the boiling point, means the T you have to calculate. Okay, W1, W2, that all these things are given. M2 is given, T0 is given, KB is given. Then first of all, we have to write the formula delta TB is equal to KBM. From that value, you have to calculate the delta TB. Once you got the delta TB, you can calculate the temperature easily. Getting that point? Very simple it is again. You practice it. If you are not getting, you can ask me. at any time. Fifth number, an aqueous solution of the compound A. Molecular weight is boils at this particular temperature. Determine the concentration of solution. By how much could be the normal boiling point of the water be raised on dissolving 3 gram of the same compound A in 84 point this particular gram of the water. They ask the temperature. Okay. Then we have to again question number 5. Molecular weight is given. Temperature is given. First of all, the concentration we have to determine is that is nothing but a molality, and by how much would be the normal boiling point of the water be raised on dissolving 3 gram of the same compound in this particular thing, that we can calculate. They are given this particular 373.72. Okay, question number 5. It is very again simple. Molecular weight is given, temperature is given. They ask to calculate the concentration. W2 is given, W1 is given, and Kb is given. First of all, you can calculate delta TB is equal to 0.12. Then molality you will get. Then calculation for delta TB is equal to Kb into m. Then we have to put all these values. We got the this change we have to show after addition of this thing. You try to solve on your own. If you are not getting, then ask me. I will explain. We will take the numerical based on this particular freezing point. See, a solution 10 number numericals or say another numerical is there. That means previous one we can see. A solution containing 0.220 gram of the certain compound in the 100 gram of the water was found to freeze at minus 0.06 degrees centigrade. Calculate the molecular weight of the compound. Freezing point of the water is given 0 degrees centigrade. Kf is given, okay, 1.86. 10 number numerical we will take. Okay. See, given things are there that identify. W1 is 100 gram, W2 is 0.220 gram. M2 we have to calculate delta TF. Delta TF is nothing but minus 0.06 degrees centigrade. That is nothing but a 272.94 Kelvin. Kf is the 1.86 kilo Kelvin kilogram per mole. First of all, delta TF is equal to Kf into M. Delta TF is equal to, then you have to substitute, then rearrange the formula for the M2 and put all these values in this equation, and after simplification you will get the answer. M2 is nothing but the 68.2 gram. All the numericals are solved by students. You have to also try for the same, then and then only you can build your confidence. Okay, please go through these things very well. If you are not getting, if you are not understood this particular part or numerical, you can freely ask. Okay, see, please go through this all this lecture very well. Please, you have the soft copy of the material. Please go through all the notes very well, because the MCQs will be based on the whole part. Okay, if you have any difficulty, any doubt, you can ask me uh, later on the Google Classroom, or say you can ask me on this particular what we can say the Telegram group. Okay, in the next lecture we will move towards the next part of this unit. Please prepare it well. Thank you.